So the CRT projector has been popular, and I shouldn't be surprised because, well, it's pretty cool. But that was kind of a quick video that I made, and I feel like I didn't really give sort of the general information. So I want to back up a little bit just to start and give some background. So this is a CRT projector, or a cathode ray tube projector. CRT projectors are pretty much the oldest video projection technology. They go back to the 1930s. That surprised me at first, but I suppose it's not really that surprising when you consider that fundamentally a CRT projector is basically a CRT television with a lens stuck on the front. It's a reasonably obvious idea. Let's clarify a little bit what I mean when I say a video projector. So film projection also goes back a long ways, and film projectors shone light through physical film in order to produce the image. Video projection entails somehow electronically modulating the light, so there's no physical film involved. The concept of video was invented for the purpose of television, and indeed, for the most part, CRT projectors were used for television images. A lot of people have said they remember sports bars having these. That's a scenario that I kind of forgot about. But yeah, in the 90s, a lot of sports bars were very proud that they had a CRT projector they could use for a really large screen image. So how does a CRT projector work? Well, in a CRT monitor, I point at one, but the thing is I actually don't own a CRT monitor anymore. In a CRT monitor, though, there's a cathode ray tube in which electrons are accelerated, they are steered, and then they strike a phosphor on the front face of the tube somewhere, which emits some light. And then, as a user, you look at the front of the tube. Well, the CRT projector is basically the same concept, except instead of looking directly at the front of the tube, a lens is used to focus the light on the front of the tube onto a screen out in front of the projector. One of the things that will immediately stand out about a CRT projector is the fact that there are 3 lenses. So if we think about a typical CRT monitor, they produce color using an array of color-filtered subpixels, basically, and then a shadow mask. And basically, a single beam is swept across dots that will actually luminesce each of the individual colors. That's a really practical way to build CRT monitors. There's more than one way that they actually work, so don't take my word that every CRT monitor is based on color-filtered subpixels and a shadow mask. There are other approaches, but that's a really common one. For CRT projectors, they take a different approach, though. As I understand it, that all comes down to brightness. So this projector is rated at 1200 lumen, which is pretty comparable with a small projector today. I actually have one sitting around, but it's buried under things, so I won't pull it out to show it to you. But similar in brightness to a typical inexpensive multimedia projector that you'd buy now. In order to achieve that very high brightness, though, they have to drive the phosphor to a really high energy level. And I think that's just most feasible to do with monochromatic tubes. So the way most CRT projectors are built is that you have 3 monochromatic tubes, and then you filter them so that one is red, one is green, and one is blue. That lets you drive them all the way without having problems with things spilling over into other holes in the shadow mask and other issues like that that make your color reproduction worse. If I dismounted each of these lenses, you'd be able to see the front of the tube directly. I might do that later because I'm going to probably clean and lubricate these lenses as well, but I didn't quite want to do it just to show you. I'll show you a clip in a minute. The thing is, you don't have to. You can look straight in the lenses and see the front face of the tubes quite well, actually. They look great. So why do we never really see CRT projectors today? They had their genesis in the 1930s, in the late 1930s, really, but I don't think they were really seeing widespread use until the 80s and 90s, when they were often being used to project a television image onto a large screen. If you wanted a huge television display, you didn't really have a lot of good options. It was basically going to be a CRT projector in almost every situation. If you needed a brighter image, you would often stack multiple CRT projectors, and then converge them together with each other just to get additive brightness on the image that you're producing. The only real alternative for television projection for a long time to a CRT projector was a type of projector that's called an iodophore. Iodophores are fascinating, and I would absolutely love to have one, but to my knowledge, there are no working iodophores left. They were fantastically expensive. And when I say fantastically expensive, keep in mind these CRT projectors typically ran 5 digits. But iodophores, I gather, typically ran in the 6 digits and not in the low 6 digits. Outside of like sports stadium jumbotrons, you did not see iodophores very often, and I think most of them were destroyed at the end of their service life. I think there's a non-working example in a museum in Europe somewhere, but there's not even very many photos of them. Iodophores are really very obscure projectors. So pretty much, if you saw a large television image, up until probably the mid to late 90s, you were most likely seeing the output of a CRT projector. CRT projectors were initially replaced by LCD light modulators. There's a little bit of nuance to why I call it a light modulator instead of a projector. Maybe I'll get one and I'll do a whole video on that because they're really interesting and they're small, so it's probably feasible for me to just pick one up on eBay. The thing about LCD light modulators is that many of them didn't do color at all, and those that did, the color was very poor. So into the 2000s, CRT projectors really couldn't be beat for color images. In fact, into and past the 2000s, a lot of people will swear that CRTs have better color reproduction than almost any modern projection technology either. What really led to the end of the CRT projector was the development of DLP. I'm not actually sure when DLP projectors were developed. I think they really started showing up on the market in the late 90s and early 2000s. But I certainly wouldn't be surprised if there were some available earlier than that, especially at higher price points. But for a long time, most of the video projectors you'd see, like in the 2000s, thinking like a school or a college classroom or lecture hall, those were almost always DLP projectors. They have a light that shines on an array of tiny mirrors that are flipped back and forth like a flip dot display in order to produce the image. A lot of multimedia projectors you see now are still DLP, but LCDs have also had their comeback. LCD technology has improved a lot. LCD projectors are capable of much better color than they used to be. And really, LCD is kind of becoming the dominant, I think, technology for video projectors. I think a lot of what they call laser projectors that use a laser light engine, I think they're often still DLP. DLP isn't gone at all. But modern landscape, it's going to be a DLP projector or an LCD projector. CRT projectors haven't really been sold since, I think, 2008 or 2009. So the numbers of them out there are really declining. Not that many people would have ever used a CRT projector, although you may very well have seen one, especially in a situation like a theater or a sports bar or sometimes like smaller sports stadiums. But a lot more people might have seen projection TVs. If you remember in the 90s especially, if you wanted a really big TV in your house, your option was a projection TV. And a projection TV was essentially a kind of limited basic CRT projector built into a cabinet in order to rear project onto the display of the TV. I had a neighbor when I was a kid who watched soap operas on a big projection TV all day, and that projection TV looked terrible. And I think it was because it was old, and just like CRT projectors, projection TVs have to be converged. You have to adjust them so that the red, green, and blue images, which are coming from 3 separate tubes, are correctly aligned. Over time, that convergence tends to drift out, and then if you don't spend a lot of time adjusting it back to be correct, your resulting image looked bad. So projection TVs really, basically this is the same concept as a projection TV, but it's built for a much larger screen, and it's built as a separate unit. I'm making a quick awkward insert because I talk about rear projection TVs being CRT projectors, and indeed a lot of rear projection TVs were built around CRTs, but I wanted to kind of fill in two DLP and LCD projection technology were both applied to rear projection TVs as well. So when it comes to any given rear projection TV, it's kind of like a projector as far as it kind of depends on when it was made, what technology it uses. My impression is that CRT and DLP were most common for rear projection TVs, and there weren't a lot of rear projection TVs that were based on LCDs, but there were evidently some. DLP was introduced to the market in 1997, so it really doesn't go that much further back than the early 2000s. So I think any rear projection TV that you saw in the 90s into the late 90s was probably going to be a CRT projector. Getting into the 2000s, it's a lot more likely that you would have been seeing a DLP model. I've gotten the impression that the original sale price of this model might have been $11,000 or $12,000. I haven't looked into that too close, so I'm not sure. Could have been higher or lower than that. As I said in the last video, it weighs about 110 pounds. So this is sort of a different world of projector than the small multimedia projectors that we tend to use today. And this has been a little frustrating because I'm trying to figure out how to get a good image out of this in my house. When you bought one of these projectors, you typically did not simply order a projector from Barco and they shipped it to you. You would buy one of these usually from a local installer or integrator, and they would send out what Barco calls a field engineer, who was responsible for the actual installation of the projector. The reason for that is that the adjustments in this projector, despite all the mini adjustments there are somewhat limited. And it's assumed that the installation situation for the projector will basically be designed around its specifications. So you'll design the room, you'll measure the screen, you'll take the dimensions of the screen, use them to calculate the correct position of the projector, and then you'll lay out the room so that the projector can be calculated at that point. Of course, I'm not doing that in here. I'm trying to use a mirror behind the camera to reflect this thing onto the wall behind me. That works, I can focus it that way, but of course the convergence is completely wrong because the mirror isn't quite on axis with the projector and it's spreading the images from the three tubes even further apart than they're supposed to be. So I'm probably going to move it to the floor later and see if I can get it squared up with that far wall a little more directly. Then I think we'll be able to get an image out of it that really gives you an idea of what one of these would have looked like. One of the reasons that I kind of set my heart on finding a CRT projector is that I've read so many people raving about the quality of the color out of these, how it's so much better than the color that you get from more modern projectors. I'm really curious to see how that turns out. My assumption would be that DLP and LCD projector technology is probably caught up. I wouldn't really think that these would have much of an advantage in practice anymore, but honestly, I'm not sure. The thing is, I have several DLP projectors available. I literally have like a shelf of them in my shed. The Albuquerque public schools, they like replace the projectors in all their classrooms. They auctioned off all the old ones, and I just couldn't control myself. I bought like 8 Prometheus short throw DLP projectors. All of them have like damaged parabolic mirrors, or not parabolic mirrors, spherical mirrors on them. It's a whole thing. I gotta clear those out of the shed sometime. But yeah, so this is a little difficult to work with. It's really assumed that this will be mounted in a room that was kind of designed for it. There were 2 common ways to install them. In a lot of like residential situations, I actually saw a commenter mention this. It was really common in like the home theaters of the wealthy to have a DLP projector that was hidden by a piece of furniture. So you'd put like a coffee table in the middle of the room that was over the projector. The alternative, which was more common in commercial, was to ceiling mount them. But because they're so heavy, you wouldn't really want to just, drywall anchor one of these into your ceiling. You had to kind of plan out an actual way to mount this into like the stringers so that you had something that could take the weight. And with how much effort mounting it is going to be, you wanted to check all your measurements and check your math before you did that so that you knew it would actually work correctly. And that's why we had those field service engineers. They were kind of the Barco reps that, saw that these would actually work in the situation they were being installed in. So that's a bit about the specifications. 1200 lumen. The closest this will focus, I measured that it depends. There were different lenses that were options for these. I wasn't sure what lenses this had on it. It seems like it'll focus up at about 6 feet. That's the closest. The furthest it'll focus, I don't know. It's probably infinity. I'm assuming the lenses go far enough out that it's functionally infinity, but I'm not totally sure of that. Certainly it'll focus off the mirror onto that wall, which is probably in the neighborhood of 20 feet. One of the other interesting questions about these is resolution. I'm going to test this with standard definition because it has S-video inputs, and that's just like the easiest thing to get working. The RGB HV inputs on this, I don't know how they're configured. Let's just get into that a little bit. This was designed to be very flexible with its video input. When you read the Barco manuals, if you wanted to drive this from a computer, they really wanted you to use an interface box that Barco sold, which took a VGA input and then converted it to RGB HV BMC connectors that would go to this projector. They wanted the cables from the interface box to the projector to be under 60 centimeters long, I think, is part of why they had that converter box. I couldn't totally explain to you why that is. I don't know if they were changing the signaling level in that converter box or what, but that's just what the manual said about how you should hook a computer up to this thing. And it's actually got a special DE9 input on the back. At first you might think it's VGA, since it's a D-sub connector, but it's a 9-pin. And that's where that Barco adapter box hooked up to this thing. The RGB HV input, I think it is likely possible to do 1080i or 1080p at a low frame rate with this projector, because it seems like most of the later CRT projectors could. I'd have to do the math, because the way, with these CRTs, especially in a more commercial context, when you look at the spec sheets, you don't get a resolution. You get a maximum horizontal frequency and a maximum vertical frequency, and then you have to kind of calculate what you can get out of that based on the bandwidth of the projector's modulation. One of the things that's nice about this projector is that it has totally electronic convergence. A lot of older CRT projectors, a lot of the convergence adjustments had to be made with a screwdriver with like potentiometers in the projector. This is a later projector, and it was kind of one of the selling points on it, that all of those convergence adjustments you can do from menus. In fact, the tray that slides out of the front that I think you'll see in a minute, it's got the controller on it, but Barco calls it the convergence tray, because most of what you see on that tray are basically amplifiers driven from programmable curves that are used to implement all of the convergence adjustments based on, digital parameters that you can adjust using the remote. I don't actually have a remote for this. I have to use the one that's wired into the back, but I might see if I could pick one up, because that would certainly be convenient. I'm going to show you what the front face of the tubes looks like on this projector, and then I think my next step is going to be an attempt to get a good image out of this. So in the first video that I made about the projector, I kind of said what some of the parts in the projector were. Later in the day, I read a lot of the service manual while I was troubleshooting, and predictably, I found out that I was wrong about basically everything. So I'm just going to make a little update on that, where I actually, give you a tour of the projector, which is largely correct. Let's take a look in the rear hatch, which is sort of the electronics bay. Line power comes in, it passes through this, which is a filter, goes to the mechanical power switch, and then for whatever reason, takes off across the projector to over here. This board, which doesn't easily come out, you'd have to remove some screws to remove it, is power factor correction. I think because of the early switch mode power supplies in this, the power factor would be pretty horrible if it didn't include these. This board right here, which has a metal cover over it with some attractive safety warnings, this is actually the high voltage flyback power supply. Barco calls this the EHT, or extra high tension supply. The kind of red sleeved cable coming out of this is the high voltage up to the tubes. This board is the switch mode power supply plus switch mode power supply subassembly, which is the sideboard. The switch mode power supply itself is responsible for producing basically all of the fixed voltages used in the projector. And that's a surprisingly long list. 9-volt standby, I know I was inconsistent in the first video about saying 5-volt or 9-volt for the standby. 9-volt is correct. There's positive and negative 9 volts, positive and negative 5 volts, positive and negative 17 volts. I believe there's a 100-volt DC that's used by the tubes. I think there might be one or two more that I'm leaving out. This also produces a variable voltage output, which is used to power, I believe, the horizontal deflection on the tubes. The amount of power that's required for the horizontal deflection depends on the horizontal scanning frequency. So there's a little complication that the switch mode power supply board actually gets a feedback signal from the horizontal deflection generator that it uses to automatically adjust that voltage. The subassembly has a couple of other responsibilities. It produces power for the fans. It has a temperature sensor built into it that modulates the fan speed based on the temperature inside the case. And it also produces a 17-volt DC power referenced weirdly. Well, let me step back a little bit and explain. This projector has two different grounding systems. There is a mains grounding system, which goes to the AC neutral, and then there's like an internal grounding system, which goes to the protective earth on the plug. Those two are not interconnected in the projector, and Barco strongly warns that they must not be. The reason for that, I do believe, is that the entire DC power system in this mostly is floating. There's one exception. There's a 17 volts DC that I believe is part of the coil power. That is not floating. It's actually referenced to the AC neutral, like, your AC power. And that's also produced by this subboard. The last interesting thing on this subboard is like sort of a safety shutdown circuit that cuts off power to the tubes if it finds that deflection power has gone below a permissible threshold. That's a protection against damaging the tubes by pointing the gun at a single point on the tube for an extended period of time. I felt like there was something else interesting to say about this. I was doing so well, just sounding so confident, and now it's all falling apart. So that's SMPS. This board is SMPS 2/G2. So this does some additional filtering. It produces a couple of additional variable voltages that are used for some of the electronics, and it produces G2 power. I'm a little fuzzy on what G2 power is. It has something to do with the tube modulation, but that's, I believe, a variable voltage power supply that this board generates. Something that's mildly interesting about this, the PFC board has rectification, and for whatever reason produces 300 volts DC. I think that's 300 volts DC with a ton of ripple. So these two boards take 300 volts as an input and then produce the various lower voltages used in the projector with much better power quality. These two boards, I had initially said this was some sort of switch mode power supply. It's really not. This board is actually the horizontal deflection generator. You might find it surprising that it's got these huge heat sinks, but I guess that helps to explain why the horizontal deflection power is a whole special thing. By far, the most power that's used in the tube modulation is for horizontal deflection. I think this thing actually produces quite a bit of current. So this is basically a power supply to the amplifiers that we'll see in a moment. One of the reasons this has the indicator lights on it, it's got that one that says short versus long. That has to do with the horizontal deflection frequency as well. Depending on whether the horizontal deflection frequency is in a lower range or a higher range, this will produce a different output voltage that I guess makes the amplifier more efficient at those different frequencies. That auto-selects as you change inputs, so I think they put that indicator light on here, just to make it easier for you to tell whether or not that's working right. This next board is the vertical deflection board. It does also have a pretty chunky heatsink on it down at the bottom, but certainly not as chunky as the heatsink on this one. This board, and this is where my memory gets a little fuzzier, but I think I'm getting this correct. This board is the RGB auto sync board. The manual refers to it exclusively as the RGB auto sync board, but I'm pretty sure auto is short for auto. So that relates to that input 4/5 that can be two inputs. If you have H and V sync from your video source, you don't need this board, and I think it's actually optional. But if you're using a video source that doesn't provide H and V sync and it needs to be recovered from the color channels, so for example, if you have sync on green, or if you want to use that input 4 and 5 as two inputs, you need this board which examines the color signals to recover the sync. It's actually got some jumpers and dip switches on it that configure it as well, so it can take the sync from different color channels. It also actually supports two totally separate modes of how it recovers the sync. I read a long section of the service manual about that. I'm going to admit I did not totally understand it. It had an info box that said something like, remember that in all cases, it is the responsibility of the field engineer to select an appropriate sync mode. So there's a little bit of pressure on you there. This board, actually, I believe this one all the way on the left, this is kind of the main video processing. So this is what takes whatever video input is in use and actually converts it to the RGB signal that will be used internally by the projector. And then this board, I believe, actually produces the vertical and horizontal modulation signals. So these are like the power supplies to actually do horizontal and vertical deflection in the tubes. This produces the modulated signal that will be used up in the tube section, we'll see, to actually apply that power to the coils. Couple of little minor details in the back here. There's these two little subboards. The one on the left is an infrared receiver. The one on the right I said was the fan power supply, but that's actually on the subassembly here. That's actually the audio amplifier for the internal speakers this projector has. I've not tried using those. I imagine they sound terrible, but I think they mounted this back here just so that it kind of gets more cooling and it's not contributing heat to other components. This empty slot right here that doesn't have anything in it in this projector, I believe that this empty slot is actually where the extra video processor for blending adjacent projectors would go. So this projector doesn't have it. That's a video processor. It's funny, the service manual goes into surprising depth on exactly how it works. It's got like SRAM chips on it that it stores curves in. It reads out the curves as it follows the beam scanning. And it can do things like rolling off the brightness at the edges of the image. It can also do a bunch of other things, but that's kind of its most obvious functionality. And that's so that when you have two projectors that are in like a grid, for example, to cover a larger screen, you can kind of carefully manually tune that roll-off to try to get it so that they really naturally blend into each other. And you don't see extra brightness in that overlap area between the two. So optional module that we just don't have here. These blanks in the back, I'm not sure what would go in the bigger one. I didn't see any reference to it in the manual. Maybe if I looked closer, I would find something. I can tell you, though, that the smaller one is where an extra RS-232 communication card would go. And I think mainly what that card gets you is that it allows you to connect a much larger number of projectors on a serial bus. I think you can always do up to 10, or it might be 9. But you can do up to 128 projectors on a serial bus for shared control if you have that module. I should say, this thing I mentioned earlier, it has 1,000,001 settings. All of those can be configured using DOS or early Windows software via serial port as well, and I am planning to try to get that working. So I think that basically explains everything in the electronics bay. There's the fans. Obviously, the manual's got like a quick one-pager, but there's going to be a caveat on everything in the electronics bay. So next, let's look up front. So here's the front of the projector. We have our 3 lenses. Normally this would look more polished, right? But I have the nice plastic cover removed, so we're kind of just looking at the actual metal chassis right now. These you loosen to adjust the Scheimpflug. I don't know a lot about how you actually do that. These two kind of set screw sort of things are used for focus adjustment. Initially, I thought this was 2 ranges, like a fine and a coarse or something, but it turns out this back one, the way the manual explains it is that this back one is for adjusting the center of the image, and this front one is for then sort of sub-focusing the corners of the image. So I think what's going on is there's 2 elements in here. I think there's an element that's mounted on this inner sleeve, and then the front element is mounted to this outer one. So first you move the inner one for most of the focus, then you move the outer one that does this last lens element, and I think that adjusts the like center to corner ratio on the focus a little bit. Remember how I mentioned there are those extra boards under there? I feel dumb that I forgot that, because when I first bought this, I looked at the front and saw this. It's just since it had been up against the wall, I hadn't thought about it. First off, the main serial ports are on the front for control. You'll see these are in and out because you can daisy chain them. There's an IR receiver, and this is for the remote came in a wired version. I think this is the internal speaker, which I assume is truly horrible. And then there's a couple of fans. And there's a couple of fans because this pops out. And I might... Let me see if I can do this. Yep. So you do not have to take the bottom of the projector off to get at these boards. They actually rather tidily slide out of the front. So, what all is in here? These three boards are like big power drivers. I will be completely honest, I don't remember what the three are all for, but I believe they are like preamplifiers for the video signal before it goes into the actual tube amplifiers. And I think they are also driven to achieve some of the settings, like a lot of the geometry and stuff that you can change basically changes curves that get sent to these amplifiers to adjust the image. You can see two of these must generate a lot of heat, right? Because they're actually ducted to their own fans. This board is actually the controller. It's got some unpopulated connectors because there's some options that would go on this that this projector doesn't have. One of those, for example, is a line doubler, which also serves as a frame buffer to get you some extra features. It is kind of cool to look at this because the service manual sort of explains the internal architecture. This is the microcontroller, kind of the main microcontroller that drives a lot of the business logic, I'll call it, in the projector. And then this Altera FPGA does basically all of the signal processing. So you're kind of, when you like mess with the menus, you're kind of changing parameters via this microcontroller that gets sent to the FPGA when you change inputs. That drives the actual sending kind of different kinds of curves and things to the signal amplifiers, and I think also to the video board to achieve your different adjustments. Okay, now let's look up in the tube section. You can see at the bottom here, the multi-pin connectors where that module that I slid out of the front connects back. And then all of these lines that come off the board and go to the tubes are actually driving the tubes. So there's a couple interesting things. The first thing to point out, these back modules on the tubes with the big heat sinks, these are like the final amplifiers. So I think these take the video signal after they've gone through the signal amplifiers in the front of the projector for like processing and geometry adjustment. And then they sort of, use the video signals to modulate the power from the horizontal and vertical deflection boards to produce the actual output to the coils in the projector. The two coils, I think this one is horizontal and this one is vertical deflection, are how those coils work out. You can kind of see that the horizontal one is beefier. Sort of an interesting thing about these is that you can see the sort of ring clamps that they're on. This one has this big kind of turnkey on it. When you buy the tubes, they don't come with these. They come just the glass tube with the neck, and then you mount these on. I have not read the service manual, but I assume that there's probably kind of a fiddly process for getting these in exactly the right position. Maybe it's easy and there's detents or something, but like this kind of looks like it's got like a fine adjustment, like threading on it. So I think that's something you have to mess with when you replace the tubes. You also have to mount the video amplifier on the back, but I think at the back of the tube, you can kind of see the socket where it actually plugs into that board to go to the elements inside of the tube. Now remember, the high voltage flyback power supply was in the back, so this potted module, this is actually like a distributor, basically, which spreads that power across the three tubes, and it's got some sort of like a current transformer in it or something like that that provides a feedback signal that goes back to the power supply for voltage regulation. And you can see the high voltage cables come out, and then they go to the coils in the front of the tubes that accelerate the electrons. One sort of interesting thing is the kind of larger Molex connectors that you see down there with the yellow and green and then blue and red. Those are the vertical and horizontal deflection signals going to the amplifiers at the back of the tubes. One of the sort of funny things about this projector is that for the million settings that it has in software, there are some kind of surprising things that it actually can't do in software. And one of those is configure the image orientation. So when I say the image orientation, I mean front table, front ceiling, or rear ceiling. And that determines if the image will be right side up or upside down with respect to the projector, and if the image will be right side forward or wrong side forward or mirrored. So basically, is the projector on a table, or is it mounted to the ceiling? And is the projector in front of the screen on a reflective screen, or is the projector behind the screen with a transmissive screen? Basically, every projector you'll ever see has in its menu where you choose from those 4 options. This does not. The way that you reconfigure it is you unplug those signal connectors and then you plug them back in the other way around. Simple enough, I suppose. The manual has a page with basically a little logic table to show you for each of those orientations which way around each of those connectors should be plugged in. It's funny to see that not as a software configurable option, as something you have to adjust in the hardware. Mostly that sort of initial setup stuff, right? Like, this thing's big, it's heavy, you're not going to move it around between front and rear projection all the time. So a lot of that's kind of a one-time thing. In software, you can basically adjust everything about image convergence, and that's sort of the stuff that would change over the lifetime of the projector as components wore out, because it's all analog. It might not even be that temperature stable, right? The manual tells you this needs to be in a climate-controlled space. I would imagine some of that stuff isn't very temperature stable either. So that's things you might have to routinely adjust. One of the big things there is the raster position. So I mentioned, like, if you had a CRT monitor, then you've dealt with the geometry adjustments. So as part of the initial setup on this projector, you have to adjust the raster position, which is just like your CRT monitor, getting the image to actually be lined up with the front of the tube. It's kind of funny because the manual tells you the way you got to do that: open up the menu, and then you got to look straight down the lens so that you're looking right at the front of the actual tube, and then you can shift around the image to get it to be properly centered and not cut off by the edges of the tube. The manual warns you that this may not be good for your eyesight, and it encourages that you turn the brightness on the projector all the way down, and I think it also actually says you might want to wear sunglasses. That might help. So, finally, and sorry my heater came on, let's do that. Let's try to synthesize all of this together, right? How does actual operation of this projector happen? Well, I'll kind of skip the power supply stuff because you probably pretty much understand that, right? A little more interesting is the video signal. So let's say we have a video signal that's going into our port 3. This is an RGB-HV input, mostly intended to be used with computers. It seems reasonably similar to VGA in the principles, but it's less specified. It's very flexible as far as frequencies. The signal from the video board, or from the video input, I should say, goes to the video processor board, which converts any of the inputs into the internal RGB-HV representation that the projector uses to drive the tubes. That's configurable. There's also memory. There is non-volatile memory in the controller, so all of those settings are stored per input. So whenever you change inputs, it is basically reconfiguring the logic on the FPGAs to get whatever configured behavior you have. That input goes to the auto-sync board, which, depending on which input you are using, may generate the horizontal and vertical sync signals if they weren't available in your input. It also goes to this board, which generates the horizontal and vertical deflection signals. So those are just the low-level signals. In the meantime, these two boards are producing the deflection power. The signals from the video deflection processor go up to the amplifier boards that you see in the front. And those amplifier boards are amplifying that signal based on dynamic curves that are coming from the controller in order to, get your correct adjustments. Finally, the signal from the amplifiers, along with the power from the horizontal and vertical deflection board, goes to the amplifiers on the back of the tubes, which produce the final power that will be used to deflect the beam. That then goes into the coils that do the actual beam deflection. In the meantime, some high current power going through the flyback supply is being used to actually drive the electrons from the rear of the tube to the front, where they strike the phosphor and produce light. So that is the whole principle of operation of the CRT projector. Fun fact, I learned from the service manual that the character generator that the projector uses to produce its on-screen menus is actually a special case of the geometry correction circuitry. So the geometry correction has a special mode where it reads out curves differently so that they are basically like monochrome bitmap data for where it should put a monochrome output. So in order to display text, basically as the beam is going by, the controller loads into the correction curve memory the lines of text. Just sort of an interesting reuse of that same circuitry to achieve that output. There are some caveats that come out of that. I don't think any are applicable to this projector, but I think if you have some of the option boards, some of those options don't work when the projector is displaying text because they use the same SRAM area, basically, that the text generator uses. So they kind of warn you that some of your geometry correction, I think especially related to the line doubler, won't happen if you're not showing a video input, if it's displaying text like the menus instead. For testing purposes, I've got this rigged up with a mirror right now. And using the mirror, I've been able to confirm that it will focus at a distance of about 6 feet. So I can actually get that set up in my house. You can see the direct reflection back to the front of the projector, which is actually pretty close to on the focus plane here. One of the interesting things about a CRT projector, of course, is that because each of the colors is emitted by a CRT, we can actually see the image directly on the face of the CRT. Now, I realize this is probably pretty terrible in the video, but you can see it's in focus at the plane of the CRT, and the lenses, this has just gone to sleep, have to refocus it onto the plane of the screen. This is also a good time to explain what I mean when I say that these projectors don't really shut off. This has gone into sort of a sleep mode because it's just been several minutes without me pushing any buttons and it's just displaying a menu. But if we take a look in the mirror, it's pretty easy to see the tubes are still on. In fact, we can see the image is still present on the front of the tube. When this thing goes into an idle state, it seems to just turn the power to the tubes very low, but it keeps the tubes on. It's pretty light in here because it's daytime right now, but in a dark room, you can still see the lenses of these glowing even when they're displaying nothing. Hey kid, want to do some drugs? So I brought the Laserdisc player in here because I don't actually have very many sources of standard definition video in my house, and the Laserdisc player is probably the best quality I have. Besides that fact, I own a couple of these virtual drug Laserdiscs from Japan, and they seem like the perfect thing to watch on this projector. Here's the catch. It turns out the S-video input on the back of the projector, despite being very much present physically, is in fact not present. The manual for this projector lists those S-video ports along with the BNC ports that I assume to be for composite video to the right of them as a future expansion. It's funny, in the manual they're not labeled in the representation of the back panel, but on this projector they are labeled S-video and video. So I'm pretty sure what's happening here is that specifically the BarcoReality 808 does not have those inputs. I think one of the normal Barco line projectors that aren't made for simulation purposes would, and they've handled that by just sort of pretending that they don't exist in the manual. In fact, according to the manual, the only inputs this has are input 3 and input 4/5, which are the two different RGB inputs. So I think to get video into this, I'm going to have to use RGBHV or RGBVH, whatever order you'd say those in, from VGA. A lot of people associate this with, I think it was Sun Microsystems machines, used to come standard with monitors that had the traditional 5 separate BNC connectors for RGB and vertical and horizontal sync. So then people ended up using adapter cables with those monitors and so on. That's basically where I'm at. The problem is I don't have any old weird Sun machines, so I don't have any of the adapter cables. So I ordered a VGA to RGBVH cable. I'm going to get just a cheap VGA output adapter. I think I should be able to drive the projector that way. Something interesting about this projector that I found when I was carefully scrutinizing the manual about inputs is that this projector simply does not support inputs with a horizontal scanning frequency of less than 32 kilohertz. I'm pretty sure that that excludes most standard definition sources. So not only does this not have the S-video input, I don't think it's even able to show the video from something like a Laserdisc player because it's actually too low of frequency. I assume that has something to do with the specific convergence boards that are in this projector, and that probably the non-reality version had a more flexible input range that would include your normal TV sources. So the bad news is I don't think we're going to be watching Virtual Drug. Maybe we will. What I would probably have to do is put it through some sort of scaler. I do have a hardware scaler, but not one with the right type of outputs for this. I could also just use my computer as a scaler, basically put it through a capture card and then output it as VGA. I'll think about it. I really do want to get this Laserdisc on this projector, but that's where I'm at right now. Once again, I am waiting for things to come in the mail.